Let's talk about absolute value. So looking at this situation here, the GMAT will often give you something that looks like this, and when they give you that, they're really telling you absolute value of x. So if we look at the difference between these two seemingly identical formulas, what you should know is that when you take the square root of a number, you only get a positive answer out. So this would be x is equal to 4. But if you're representing it where x is squared, giving you a positive answer, the original x could have been positive or negative. So I get x equals positive 4 or negative 4 from the second situation. Looking here again, if I put a negative 4 in for the x in that formula, I would get negative 4 squared, and then I would square root that answer. And that gives me the square root of 16. And the square root of 16 is just positive 4. So I get the absolute value out when I run any number through this process. And that's why this process is equivalent to the absolute value of x. So if you see the square root of a number squared, think the absolute value of that number. All right, so let's look at solving absolute values. If 4 equals the absolute value of x, that means that x was either equal to positive 4 or negative 4, because those are the numbers I would put inside the absolute value and then turn positive to be equivalent to 4. So whenever you run something through an absolute value, whether it's absolute value of positive 3 or negative 3, you're going to get positive 3 out either way. It just yields the positive version of the original number. So you just lose the original sign, it becomes positive. Now when you have a formula like this, what I get is two answers. One of the answers will basically just be the equivalent to the original. X is between 2 and 5. But I know that I could plug negative 3 in here and it would still work, because the absolute value of negative 3 is 3, and 3 is between 2 and 5. And so if I plug negative values in, I would flip around my inequality symbols, and I would get x is greater than negative 5 and less than negative 2. So I just put negative signs in front of everything, and this is if x is negative. Notice I'm not calling it negative x because I'm actually saying the value of x was negative, not negative times the value of x. So if x is negative, this is our situation. If x is positive, it's between 2 and 5. Now sometimes you get a weird situation like this, where instead of getting two formulas out, you actually get one formula out that overlaps the zero bound. So in this situation for the absolute value of x, if it's less than 2, then I know that x is less than 2 is one version, and x is greater than negative 2 is another version, which means x is between 2 and negative 2. So on a number line, x would be between negative 2 and 2, and if we test values here, does this statement hold true? That if I fill in from here to here, I can get values that work in this situation. Let's plug in negative 1. If I plug negative 1 in here, I get the absolute value of negative 1 is less than 2, which means 1 is less than 2, and that is true. So this works. If I plug a positive 1 in, it'll definitely work. If I plug 0 in, absolute value of 0 is 0. Is that less than 2? It is less than 2, and so that would work as well. And basically, the points negative 2 and 2 are not included in this number line because they don't follow this rule. The absolute value of 2 is not less than 2. That doesn't work. So these are not included, but we can go all the way down to like negative 1.99999 and the positive version of that as well.